shows in black for the font. We actually just change the font now, okay?
Alright, if you want to do that very quickly. Now, rule of thumb, if you have a dark background, try to use a light color or a really different kind of color. Like, see where it's kind of black at top and then it kind of gets lighter? Sometimes you might actually have to use different colors on your fonts.
Right there. Oh, now I can get that.
Yeah, so green would be a good one. Ah,
okay.
Much better.
Water molecules participate in hydrogen bonding. Surface tension is an inward force or pull which tends to minimize the surface area of a liquid. Surfactants are a surface active agent and substance whose molecules interface with the hydrogen bonding between water molecules, producing surface tension. Soaps and detergents are surfactants.
A surfactant. You know what's a good example of surfactant? You know how you wax your car and it rains and you see the little bubbles pop up? Well, if you were to wash your car at that moment, the water molecules would flatten out.
Alright. Okay, heat capacity of water.
So,
the specific heat of water is higher than many other substances. Water heat of vaporization is higher than any other liquid substance at room temperature. Ice is less dense than its liquid counterpart, water. As a result, it floats. This is unusual behavior for a solid because it usually sinks due to higher density. Ice behaves differently because the structure is a very open framework. When it melts, it collapses and its molecules pack together, making a dense. Actually, one thing, if you look at the snowflake in the background, what shape does it look more like? Looks kind of like a honeycomb.
Interesting enough. Yeah, but you notice the V shapes on the snow crystal there?
Hexagon.
Hexagon. What you're going to find is you're going to find that V pattern because of the water molecule, and it just sort of builds upward. So look, you got a V here, you got a V there, there's a V shape here, a V shape here, and you're going to find that in most ice crystals. That on a real small level that you can't see, you got that hydrogen bond, but because they stack up and they fit together like a jigsaw puzzle, they build up into that crystal kind of shape.
Okay.
Which is cool.
Ice melts at 0 degrees centigrade. Heat absorbed when 1 gram of water changes from a liquid to a solid is 80 calories per gram.
Hey, I always wondered, how come that expression, no two snowflakes are the same?
I'm not sure.
Anybody got any theories on that?
Aqueous solutions.
I guess not. Wait a minute. Chris, nobody answered my question, and Alex is laughing. How come no two snowflakes are alike?
Because they have unique patterns.
Why?
Because they form differently.
But is there an infinite number of patterns?
Well, let's look at water. Is there something like water just floats around? It's never in a single pattern. It's just jumbled around together.
Yeah, but if it crystallizes, it's becoming more of a fixed pattern, right?
Yeah, however, it's only in the pattern and whichever was lasting as water.
Guess what?
Yeah.
When you're thinking of that one little molecule, there's only certain ways you can sort of arrange the water molecule, right? You can twist it all around.
Yeah.
But remember back to Avogadro's number? 6.02 times 10 to the 23rd power?
Yeah.
That's 6.02 with all those zeros after it. How many combinations could you make of those?
I guess I'm finished.
And that is one small little unit of it. That ice crystal that you showed is billions of Avogadro's number. That's why there's so many patterns you can come up with. It's infinite. Thank you, Chris, for your
Alright.
patience.
An aqueous solution is a water sample containing dissolved substances. A solvent is a dissolving medium. Solute is the discharged particles.
I think it's dissolved.
Yeah, dissolved. I can't see it because of my picture.
Yeah, well, you notice again, you got a black background, so again, using maybe a slightly different colored, a darker colored background. A dark colored
Majority of it is
picture.
white.
Yeah, and so it really picks up there. So like when you change it to that green color or blue color, that'll show through the red and the black and white color.
Okay.
So
Anyways,
So you keep going.
solutions are homogeneous and stable. Substances that dissolve most readily in water include ionic compounds and polar covalent molecules.
okay. Yeah, I like the picture in the background too, because you kind of see that sodium atom in there. And there you got the chlorine atom. Good, I like it. And you notice the watermark. Chris, that was an excellent two slides. Backgrounds.
Oh, thanks.
I like the way it is because you got the negative charge with the positive hydrogen. Good.
Alright.
And
Great, I'm glad you like it. Okay, solvation occurs when a solute dissolves in an insoluble ionic compound is a compound that has attractive forces within the crystal which happen to be stronger than the attractive forces exerted by the water.
that would be like me and Jose arm wrestling.
I guess.
He's
Okay.
stronger than me, so he would win.
You
So
sure?
that's what they're saying there. We will both lose to you, though.
Yeah, yes, sir. Alright. Anyways, water hydration is the water in the crystal or water of crystallization. If a hydrate has a vapor pressure higher than that of the water vapor in air, the hydrate will effluence by losing the water of hydration. Effluence is to lose water of hydration. The process occurs when the hydrate has a vapor pressure higher than that of water vapor in the air. Salts and other compounds that remove moisture from the air are hygroscopic. Hygroscopic substances are used as drying agents or dissecants. A dissecant is a hygroscopic substance used as a drying agent. Dilucent and the compounds remove sufficient water from the air to completely dissolve and form solutions. A dilucent is a term describing a substance that removes sufficient water from the air to form a solution. The process occurs when the solution formed has a lower vapor pressure than that of the water in the air.
Now, do you guys ever buy like cameras or electronic equipment? You usually find little packets in there called silica gel.
I put an iFlip on my Christmas. You're talking about video cameras, right?
Yeah, like video cameras.
Well,
and
I'm
stuff.
gonna get an iFlip for Christmas.
Well, that's nice. But when you get the electronics to be packaged, they can be damaged by high humidity and moisture.
Oh,
So they
yeah.
put those little packets in there, and you use they're called silica gel.
Oh, I know
They
those.
absorb moisture to protect your camera during storage or your
Oh.
electronic device during transport or something.
Oh, so you can't.
Just gotta fix something right
So
You
there.
can fix this.
So you can't put them in humidity.
No, most electronic
Oh.
equipment will be ruined by heavy moisture.
No
So that's
wonder.
why, let's see, we say, okay, keep computers wherever possible in an air-conditioned room.
Ooh.
Don't keep it out in like the moist, humid, wet place, because if water gets onto the electronic circuits,
Like the kitchen.
well, like a humid place. I mean, the kitchen is not going to be a problem.
Okay, good.
Most of the time.
That's the only place.
But
I
if you
can
kept
put
it in the
computer.
bathtub, that might be a problem. If you tried to use your computer in the shower, that's going to be a problem.
Alright,
Our electrolytes, let's
and
go here.
non-electrolytes. Compounds that conduct an electric current in aqueous solution or the molten state are electrolytes. Compounds that do not conduct an electric current in aqueous solution or the molten state are non-electrolytes. When a weak electrolyte is in solution, only a fraction of the solute exists as ions. A weak electrolyte is a solution in which only a fraction of the solute exists as ions. When a strong electrolyte is